So it begins. TypeScript has been dominant in the web development space, addressing an important gap in both the safety and maintainability of front-end applications. But a new challenger is here that outperforms TypeScript and will change the way that you develop the front end. I've been a web developer for 14 years, and I've spent the last year researching new web dev technologies. This new challenger has the best of both JavaScript and TypeScript, plus a lot more. In this video, I will name the challenger and, more importantly, tell you why it's a game changer for the front end. I will show you how it outperforms TypeScript at enabling developers to write simpler, more maintainable code with greater speed and confidence. But first, are there signals that TypeScript is losing its dominance? Recent industry signals suggest a growing frustration with TypeScript's limitations. Projects like Svelte have abandoned TypeScript, citing tooling friction, while Basecamp have done the same, citing ergonomic issues, forcing their developers into complex workarounds. This creates room to discuss alternatives. Before we discuss our challenger, let's first talk about TypeScript's design. This will help us understand its limitations and why this new challenger is a game changer. TypeScript is described as gradually typed. It is a superset of JavaScript with compiler configurations that allow for its adoption to various degrees of typing. This has been a game changer for JavaScript, as TypeScript could be applied on top of JavaScript codebases to provide more safety and certainty at compile time. Unfortunately, TypeScript's approach towards gradual adoption has made the experience of type safety different for each codebase and the experience inconsistent from project to project. Developers can carry assumptions about how TypeScript works from codebase to codebase, which is dangerous because the whole point of a type system is to eliminate assumptions about how code works. This means that, dependent on the compiler configurations, TypeScript can be unsound, and this is actually how it describes itself. This means that it can't fully determine at compile time if some operations are safe. That's unfortunate because the whole point of a type system is to ensure soundness in your code before it goes live. TypeScript's approach to gradual adoption creates concrete problems in real code bases. Firstly, undefined means everything and nothing at the same time. TypeScript leans heavily on undefined as the catch-all indicator of absence, and this over-reliance creates subtle but pervasive problems. Because the language must remain compatible with JavaScript's dynamic nature and support gradual adoption, its type system isn't expressive enough to distinguish between the many different reasons a value might be missing. So let's take a look at how this example combines all the problems that could have occurred into a single undefined. So here we have a list of users that we're loading from the database, and we have a dynamic index to access to pull one of those users out. Now, all this compiles, we're using strict mode, we're using no unchecked indexed access as the compiler option. And when we run it, let's take a look at what happens. We have undefined, undefined, and undefined everywhere. So undefined in line 18, undefined in line 17, and undefined really in line 16. So here we have undefined to indicate that something was absent from the database. Then we have undefined to indicate that the user is absent. And then we have undefined to indicate that a property of the user is absent. And so it kind of blurs the lines. We have undefined meaning everything, and at the same time communicating no information at all, really, about the source of the problem. Now, this will affect the maintainability of your application, and it'll affect the speed of your developers, because instead of getting an informative error message about where the problem is really located, we have this sort of stack of undefineds that we've got to work through to find the real source of the problem. Number 2, TypeScript has exhaustive type checking, but with an asterisk. You have to have the correct compiler option set in the tsconfig file, and you have to have it coded correctly for the compiler to reveal unmatched cases. This involves specifying a default case and using a never type, and neither is required for you to have TypeScript code that compiles. So looking at our example, we have a typed union of literal string types in this direction type. And we have two functions, move1 and move2, which switch on this. Now they're coded two different ways. One uses the default case, but not the never type. The other switch statement does not even use the default case. Both of these are prone to breakage if the semantic meaning of direction changes. So let's expand what direction means, and let's not only include up or down, but left and right. Now, this code compiles, runs, but doesn't reveal the fact that the definition of direction has been expanded upon, and will not reveal the fact that these cases are not being handled in either one of these switch statements. I want you to note as well, while we're here, how many ways there are to write a switch statement. So this example that I've shown you directly impacts maintainability and simplicity of the code. Thirdly, TypeScript manages the presence of null or undefined in your code base. Due to its approach to gradual adoption, there are still many ways in which null or undefined can resurface at runtime, depending on your configuration settings. Whether it's through the use of the anytype or assertions such as the non-null operator, the presence of null still remains a threat that TypeScript has not completely eliminated. Our top challenger is a new web dev language. Not only does it fix all of the aforementioned problems with TypeScript, but it has excellent interop with the JavaScript ecosystem. It integrates with minimal friction, and its syntax is so similar to JavaScript and TypeScript that it makes it easy to learn and ergonomic to use. Welcome to Rescript. Some of you may have already heard of it, as it's starting to gain some traction recently. But even if you have, there's a high probability that you're unfamiliar with all of its amazing features. So let's take a look, starting with the first. Rescript has been designed to look a lot like JavaScript. It accomplishes this through its strong type inference, which allows you to annotate the code with as little or as many types as you like, often leaving code that resembles JavaScript. If you'd like to get a sense of the syntactic similarity between JavaScript and Rescript, I suggest you visit this comparison to JS section in the Rescript docs, which I'll be sure to link to in the description. Rescript not only looks like JavaScript, it compiles to JavaScript in your codebase, which gives it excellent interoperability with the JavaScript ecosystem. You can import any JavaScript package that you use in your existing code bases today can be imported into your Rescript code. And in fact, you need look no further than the Rescript source code to see that they use Mocha and node assertions for their test suite, and I'll be sure to link to those in the description. The core team maintains first-class bindings for React and supports JSX, so this makes Rescript ready for the web today. When Rescript compiles to JavaScript, the JSX is preserved so that you can leverage your existing toolchain to process the Rescript output, as you would any other JavaScript file. Now, Rescript components can be embedded as children or parents of your existing React or TypeScript components today. This means that it will fit anywhere in your component hierarchy of your TypeScript and React codebase. Now, to prove this, I have a video at the end that shows you exactly how to do this. TypeScript's approach to gradual adoption is to gradually increase the level of typing in your codebase. Now, Rescript has gradual adoption too, but it's different. The type system is sound and complete, and the presence of Rescript simply grows in your codebase as needed. Now, to see how easy it is to install and integrate alongside your existing JavaScript, TypeScript, React codebase, be sure to stay tuned to the end where I'll show you how to do exactly that. Rescript's new build system is very fast and outperforms TypeScript for incremental builds. Now, Rescript's compiler targets individual files, and since its module system is a strict DAG, features like precise incremental builds and parallelization are made possible. Rescript has a completely sound type system. This means that we can have certainty about the safety of operations at compile time, and this is a stronger guarantee than TypeScript. Now, Rescript is adopted gradually, but its type system isn't, and that's the key. Thankfully, this means the experience of Rescript is the same from project to project, codebase to codebase. TypeScript's type system is unsound, partly because it covers the entire feature set of JavaScript. Rescript's approach is simpler, seeking to provide a complete type system for a smaller set of the JavaScript feature set, focusing really on data and functions over classes. Now let's get into how Rescript solves the specific pain points that we brought up in our previous TypeScript examples. So let's talk about null safety first. So null doesn't exist in Rescript. We talked earlier about how TypeScript still has the presence of null. It simply manages it in your JavaScript code base. Now, Rescript's strategy is to remove null altogether while generating null-safe JavaScript code as output. This means that you'll never have null-related bugs at runtime ever again. So how does Rescript manage the presence or absence of something? Let's take a look at our familiar example from one of our prior TypeScript examples where we had loaded users from a database and selected a user out of an array by index. So here we have type user with two fields, ID and name, and we have a function to load users from a database. If you're familiar with TypeScript, I'm sure this would look quite familiar to you. If you are familiar with JavaScript, with only JavaScript, then this looks equally familiar, okay? In reality, this has a return type, but it's being inferred because Rescript has great type inference. And this is actually an array of user. We can specify that, we can not specify it. It's up to us. Now, we finally have this getUserByIndex function, and if you could guess, what is the type, return type of this one? If you're in the JavaScript world, it would be something like user or undefined. If you're looking at how we're accessing the user by index, but that is actually not the case in Rescript, because however we access an array by index, whether directly like this or through a belt utility, like we could do belt.array.get. However we do this, it's going to result in not a user, but an option of a user. Okay, so if you're familiar with Rust or Java or any modern, any of the more modern strongly typed languages, then you'll be familiar with the option type. So this is an option of a user, but no matter how we access it, whether we do it in the kind of familiar JavaScript way or not, we still get an option of a user. And then we can see directly below that is indeed true. We're switching on the user, on the option type, and either it's some or it's none. Okay, so we could, if we absolutely wanted to, say we were optimizing, because an argument can be made that doing a check at runtime has a cost. Well, I mean, if we absolutely want to return a user unsafely, we can do that by. But the nice thing with Rescript is that you have to specifically use methods that call out unsafe practices. So, for example, in Rescript, that would be belt.array.getUnsafe. Okay, and then you could pass the index, and then you would get a user by index. Notice how the Rescript compiler is compiling, and it's saying, you can't switch on, like expected user to be a option type, and it wasn't, right? It's just a user. So that is how in Rescript we manage the presence or absence of something. In Rescript, exhaustive checking is complete. There's no way to craft a switch statement that accidentally causes runtime errors, and there are no settings to adjust it to make it behave differently. It just works. So let's take a look at our move function that we had crafted prior in TypeScript land. If you remember, over in that example, we had two examples, move one and move two, and the switch statement was crafted a little bit differently. One had a default case and one didn't. And what we demonstrated was that as we modified the type alias direction and added more to the set of string literals, which is up, down, and so on, that define that type alias, we noted that the switch statement was not able to detect that some cases were not being matched. Now in Rescript, the direction is actually a variant. It's called a variant, and up and down are called type constructors. So as we expand, now this is safe. It matches fully the cases for this given type. Now, as we expand and add more type constructors, like left, for example, and right, we'll notice right away that the compiler will note that not all cases are being matched. You forgot to handle a possible case here, for example, left and right. Now, there is no way in Rescript to craft a switch statement other than the way that we have. So there's really only one solution. There are no pitfalls, there are no gotchas. You just simply have to handle the additional cases. So here, it's for the case left, it's moving left, and for right, it's moving right. And as I save it, the warnings go away or the errors go away, and the compiler is satisfied that we've matched all cases. So let's just take let's run this. And yeah, moving up, moving down. I can say moving left or moving right, and the code just works. Great. So for our final example, let's revisit the code that we were operating on prior. And we had been using the option type to manage the presence or absence of null. But if you remember in our TypeScript example, it was just kind of undefined, a stack of undefines all the way down. It was undefined when we couldn't get the element out of the array. It was undefined when we logged the user, and it was undefined when we safely tried to access a property of that user. And so it's kind of undefined everywhere, which for everything, which kind of means nothing. So I guess what I'll do for this is I'll show that Rescript's type system is adequately standard. Like it's at the level of what we need for the modern web and to represent the reality of the operations that we're trying to perform. So for example, it probably would be more appropriate in the getUserByIndex case to return a result type, something that that TypeScript doesn't represent all that well. So for example, let's return a result of the user in the case where it works out, or a string in the error case. So, with a result type, we either get an OK response or we get an error. So we could do that a number of ways. Let's just for now switch on the user, and in the case where we find one, we are going to return OK with the user, and in the case where we didn't find the user by that index, let's just return an error message. Could not find user. Okay. Now, we're going to have to modify this switch statement. It's going to have to be OK or error. And in the case where, in the error case, I think we just want to log the error message. All right, now there's no conflation of accessing the username, the property of accessing the field of the user, the .name, and there's no conflation of an error there with an error in getting the element out of the array or accessing it from the the database, or whether the user is actually there or not. So when we look at this code that we've written, there's no possible way to conflate one error for another. In the case of TypeScript, undefined meant several things. It meant either that the property wasn't present in the user object, or the user was actually just undefined, or that we couldn't get the user was not found in the array. There's no possible way in Rescript to have a conflation of errors like that. We have clearly a result type for the getUserByIndex function, and our type system is strong. We know at compile time we have certainty about the types, and that's why we're able to access the user.name field safely and with certainty. Rescript presents a serious challenge to TypeScript's dominance. Industry signals suggest a growing frustration with TypeScript's limitations, which opens the door to discuss other options. Rescript is by far the strongest challenger, offering the safety and reliability that TypeScript promised, but with true soundness and simplicity. As the web ecosystem continues to demand higher reliability and performance, Rescript is ready for the web today, providing a clear path forward without sacrificing the JavaScript feel that we love and know. With no opportunity to bike shed on compiler settings, the experience of Rescript is consistent from project to project, simplifying maintenance. Now, if you still don't believe me that Rescript is ready for the web today, then check out this video.